Before we start, tell me one thing. What do you think this code will print? Most of the developers says start, timeout, promise, and then end. But that's not correct. The output is start, end, promise, and timeout. Wait, timeout has 0 millisecond, then why didn't it run first? If you ever been confused by JavaScript behavior like this, today we are finally going to understand the event loop deeply. To understand event loop, we first need to understand one important thing. JavaScript is single-threaded. JavaScript can only do one thing at a time. Imagine JavaScript is like one chef in a kitchen. The chef can cut vegetables, cook food, clean dishes, but he cannot do all of them simultaneously. He must finish one task before moving to the next. That's exactly how JavaScript works, one thing at a time. So now the question becomes, if JavaScript can do only one thing at a time, then how can it handle timers, API requests, promises, and button clicks? This is where the event loop comes in. To understand event loop, you need to know these first. Call stack, web APIs, callback queue, microtask queue, and event loop. Call stack. This is where JavaScript executes code. Think of it as JavaScript's to-do list. Function goes in, functions comes out, one by one. Web APIs. JavaScript itself cannot do set timeouts, fetch requests, DOM events, right? These are handled by the browser. The browser gives JS superpowers. We call these web APIs. Macrotask queue, also known as callback queue. This queue stores set timeout, set interval, DOM events, and callbacks. These are called macro tasks. Microtask queue. This queue stores promises. Queue microtask, mutation observer. These are higher priority tasks. Now the last one is event loop. The event loop acts like a manager. It constantly checks, is the call stack empty? If yes, it first executes microtasks, then macrotasks. This order is very important. With the help of these 5 components, now let's try to connect all of these by our code snippet. Line number 1 goes to the call stack. Print start immediately on the screen, and it is removed from the call stack because its execution is completed. Line 2 goes to the call stack, but since it's a set timeout, does JS wait? No. It sends it to the web API. Browser starts timer, even though it says 0 milliseconds. 0 means minimum delay, not immediate execution. Once timer finishes, it moves to the callback queue, the macro task queue. When JS will run the promise, it is again an async task. It will be handled to web API, but when the response comes, it will go to the microtask queue. This is super important. It has higher priority over set timeout, so it will not be moved to the macro queue or callback queue. It will be moved to the microtask queue. Promises always go to the microtask queue. Console log n goes to the callback stack, then it will print end and it will be popped out of the call stack. Now there is no more code in the script. Event loop activates. It will ask if call stack is empty. In our case, yes. Then it will check either micro queue has any tasks Yes, we do have promise dot then, so it will push that task to the call stack. So it executes and print promise on the screen. Now microtask queue is empty, so event loop will check tasks in the macro queue. If there is any task, that will be pushed to the call stack. In our case, we have set timeout, so the set timeout will be executed now via the call stack. So we will see timeout on the screen. Please note that microtask queue always have higher priority over macro task queue. Set timeout interval always goes to the macro task queue, but promises always queued to the micro task queue because they are high priority. When the call stack is empty, event loop will get activates and it will always clear the micro task queue first. In our case, we only have promise, but here if we have 10 promises, then it will execute those 10 promises first, and after that the set timeout will be executed. This is the part that confuses almost everyone. Many developers think set timeout 0 means immediate execution. Wrong. Event loop rule. All micro tasks execute before macro tasks, meaning promises always beat set timeout even with 0 millisecond. So now this is one more example. What do you think will be print on the console? Write your answer in the comments. So console.log will go to the calls. Console log 1 will go to the call stack and it will be printed immediately and removed from the call stack. Set timeout will go to the call stack, but it will be handled by the web API, and after completing its time, it will be moved to the macro task queue. Then we have promise. It will go to the call stack and via web API, it will be moved to the micro task queue. Then we have one more promise. It will do the same, will go to the call stack, then via web API, it will be put it into the micro task queue. Then we have console.log 5. It will go to the call stack, immediately prints 5 on the screen and will be removed from the call stack. Now our call stack is empty, so event loop will get activated. It will check the micro task queue first. Since we have two promises here, so the first promise is 3. It will print 3 on the screen, then it will print 4 on the screen. And after that, after clearing the micro task queue, event loop will move to the macro task queue. Yes, it have set timeout, so it will print 2 on the screen. So the output should be 1, 5, 3, 4, 2. Now the question is, why should you care about it? Because event loop affects async code, API callbacks, React rendering performance, interview questions, debugging weird JS log bugs. When you understand event loop, JavaScript suddenly starts making sense. If this finally made event loop click for you, please hit the subscribe and comment part 2 if you want me to explain async await internally. Thank you for watching.